Hey guys, welcome back to Voltage Learning. In today's video, we have a complicated looking circuit with two current sources, one of 2 amps and the other of 4 amps. Our job is to find the voltage across R3, the 400 ohm resistor, directly in the middle of the circuit. We can solve this problem pretty quickly in 3 simple steps if we break it down. So let's get moving. In step 1, we have to first establish ground. The circuit doesn't have ground established already, so let's just simply assume that the bottom node at the bottom of the circuit, or the 400 ohm resistor, is going to be ground or 0 volts. This is going to be really important in our subsequent step 2 and step 3. Speaking of which, in step 2, let's apply Kirchhoff's current law, or KCL, to the top node of the circuit. If we isolate that node, we see that there's 4 amps flowing through the 800 ohm resistor and 2 amps flowing through the 100 ohm resistor. If we draw a simple diagram of that node itself, there's going to be 2 amps into the node, 4 amps into the node, and then I3, or the current in R3, is going to be the unknown, which we're going to have to solve for. Now, according to KCL, all the currents within that node must equal 0. Therefore, 2 amps plus 4 amps minus I3 is going to equal 0. If we solve that, we get 6 amps minus I3 equals 0, or I3 equals 6 amps. Next, in step 3, finally, all we do is use Ohm's law to calculate the voltage. We know that V equals IR is the Ohm's law. Therefore, V equals 6 amps, which we calculated in step number 2, times the 400 ohms gives us a final answer of 2400 volts, which is across R3. And there we have it. First, we established ground at the bottom node of the circuit. Then we applied KCL and isolated that top node with all the incoming and outgoing currents. And then finally used Ohm's law to calculate the final voltage being 2400 volts. So if you want more circuit to practice problems or interview help, visit us at voltagelearning.com. And don't forget to like, comment, and subscribe. Until next time, we'll see you guys later.